Now, one of the first topics we want to talk about is a theory. Now, a theory is not an unfounded guess or conjecture, and it's not simply a dogma that you have to believe. Throughout this class, I want you to focus on why do we believe that theory? Why is that model for how we understand things a good model? So what is a theory? Well, it's a model. It's a way of explaining some aspect of the universe, of the world around us, that gives us some predictive power. And to give us predictive power, it has to be supported by evidence. Many times, the models we use are mathematical models, abstract models, where we use equations and variables to represent certain ideas in physics, to represent certain ideas about the world around us. And we use the math to allow us to make predictions and to learn things about the universe. So let's consider a real-world example that I might use some thinking and some math to gain some more information and some predictive power. Let's consider if we arrive at the mall and the parking lot is totally full, as we can see in the screen here. What are we going to do? Well, one thing you might try doing is to stake out a position where you can see many spaces at once. Let's suppose you can see 20 spaces. We would like to be able to predict how long we're going to have to wait before one of those 20 spaces is likely to open up. Well, we're going to make a model. Making a model means we're going to simplify it, generalize it, estimate, and make assumptions so that we can apply some principles and facts to make some predictions. Obviously, we don't have the power to predict exactly what's going to happen, but maybe using these ideas, we'll be able to get some sense of about when we expect a space to open up. Simplify, that's the first step. We can't predict exactly the waiting time, but maybe we can get an average waiting time, especially when we consider a lot of spaces at once. Generalize. Maybe 20 spaces, there's nothing special about that. Maybe if we consider a general number n of spaces, we'll be able to get more insight. Maybe we'll want to simplify even further by considering just one space at a time. Then we can go to 2 spaces, 3 spaces, maybe 20 spaces, maybe more spaces. Okay. The next thing we might want to consider is estimating. So one thing we might estimate is how long do people spend shopping? Now, obviously, there's a lot of variation in this. Some of you may go into the mall, go in and out within 15 minutes to buy one specific purchase. Others of you can hang out the entire day in the mall. But I would guess that on average, people spend a couple of hours shopping in the mall. So let's take that as our estimate for how long on average most people spend in the mall. So about 2 hours or 120 minutes. Once we have these simplifications, we can make reasonable assumptions. So for example, maybe we will assume that people arrive at evenly spaced intervals. Now you may argue that's not very valid of an assumption. No, but when we have lots of people, the variations in how often they arrive and the variations against the 2-hour time, all of those tend to even out. So it's not such a bad assumption to assume they arrive at evenly spaced times. Then, if we considered having 3 people, well, we would imagine that with 3 people, one of them would have arrived nearly 2 hours ago, sometime between 120 minutes ago and 80 minutes ago, in this range right here. The second person would have arrived somewhere between 80 minutes and 40 minutes ago, and the third person has arrived fairly recently, within the last 40 minutes. Well, from this, you can see we can actually make a prediction. If we were looking at 3 spaces, we would expect that one of those 3 people arrived more than 80 minutes ago and will be finishing up their shopping within another 40 minutes. So we would expect, if we can follow one space, that we would find a space opening within 40 minutes. Now you may say 40 minutes, that's a horribly long time. True enough. But what we did there was we took 120 minutes divided by 3 spaces, and we found that we would wait on average, or somewhere between 0 and 40 minutes for a space. Now, if we can command 20 spaces, then I would expect to consider 120 minutes and divide it by 20 spaces, and I would expect to wait somewhere between 0 and 6 minutes. Perhaps that's still longer than you want to wait for a space, but it wouldn't be unbearable.